All right, welcome back, Hononegah Honors, Algebra 2, Section 5.4. We're going to start getting into solving equations that have radicals. So an equation with a radical, it is one of the variables has to be under the radicand. An example of this would be 2 square roots of x plus 1. Now, we're not going to solve that one, but ultimately, that's what a radical equation would look like. So the first step is you have to get one of the radicals by itself. So you have to isolate one radical. Now, there might be more than one radical in a particular question, so you ultimately have to get one of them by itself. Then raise each side to eliminate the radical. So if it's a square root, then you would square both sides. Or if it's a cube root, you would cube. If it's a cube root, you would cube both sides, and so on. And then solve the resulting equation. So here we go. I first have to get the radical by itself. So there's a 2 outside. So I want to go ahead and get the radical by itself. Now, because it's a square root, you would square both sides. Now, squaring both sides does not get a plus or minus. That is a common mistake. Taking the square root of both sides does. So now, subtracting 2, and x would equal 14. So when I plug 14 into this particular equation, it works because 14 plus 2 would be 16. Square root of 16 is 4, and 2 times 4 would be 8. So again, squaring both sides to get rid of a square root. Next, I'm going to add 2 to both sides. I'm going to cube both sides. Add 5. And divide by 2. So again, isolate the radical and then do the opposite. So if it's a cube root, the inverse, the cube root, you would cube both sides. A square root, you would square both sides. Now, we do have, here's a word problem. In a hurricane, the mean sustained wind velocity, V, is modeled by V of P equals 6.3 square root of 1013 minus P, where P is the air pressure at the center of the hurricane. Estimate the air pressure. They want you to find P in this question. If the hurricane has a sustained wind velocity of 46.2. All right, so how would I go about solving that? Well, I need to isolate the radical. So I'm going to have to divide by 6.3. So 46.2 divided by 6.3. I get 7.3 repeating. And then square both sides. So square that. I get 53.78, give or take, equals 1,113 negative P. So now subtract 1,013, negative 959.22, and then divide by negative 1. So P is equal to 959.2, and then we're talking about millibars of pressure. Next. Now, you do have to worry a little bit about when you square both sides. Anytime you're squaring both sides, you have to worry about what's called extraneous solutions, or solutions that don't actually work. When you use this procedure, you should always check your answer. Now, it's not going to make a big difference when you have just a positive number on the other side, which, by the way, all square roots need to equal a positive number. You couldn't have the square root of x equaling negative 2 and get a real answer. So again, you can't take the square root of anything and get a negative. Because now when I square both sides, I get x to equal 9. The trouble is sometimes we're going to put a letter on the other side, which does then cause a more degree of difficulty, and some answers will work and some answers will not work. And these are extraneous solutions. So you always have to check. Now, you actually never have to check if it's a cube root. Okay, because you can take the domain and the range of a cube root is all real numbers. So you only have to worry about it when it's an even root. All right, here we go. We're starting off with a tough one right off the bat. We're going to square both sides, and I can't stress that enough. You're not squaring each individual term, you're squaring both sides. So 2x plus 7 would equal, it's x minus 4 times x minus 4, which is x squared minus 8x plus 16. So again, when you're squaring a binomial, you have to FOIL it out. Now, it's a quadratic. So I have to get everything equaling 0. And now all my techniques that I learned when solving a quadratic, such as factoring, set the parentheses equal to 0 and solve. So x is equal to 1 and x is equal to 9. Now, both of these, x is equal to 9 works, but x is equal to 1 does not. So let's go back on the original one and talk about this. If I plug 9 in, so 9 minus 4, which is 5, and I end up with the square root of 25, and that's true. Square root of 25 is 5. But let's plug 1 in and show you why that one doesn't work. 2 times 1 plus 7 is the square root of 9. But 1 minus 4 is negative 3. Well, the square root of 9 is not negative 3. The square root of 9 is just 3. So therefore, that's why this one doesn't work, okay? And so you must cross that out. You please make sure on your test that you actually cross it out. Otherwise, I will not know that you meant for that not to happen. Even though I just circled the 9, I really need to cross out the ones that I am not going to use. Squaring both sides. Now, this one is pretty in-depth, not going to lie. I'm going to square this entire side. So 7 minus x, that's not a big deal. But the square root of x plus 6 plus 1 times the square root of x plus 6 plus 1 is a little more in-depth. When I take the square root of x times the square root of x plus 6 times the square root of x plus 6, you're going to get x plus 6 because it's the square root of x plus 6 squared. This would be 1 square root of x plus 6. This one would also be 1 square root of x plus 6, and this would be just 1. Now, add like terms. So I get x plus 7 plus 2 square roots of x plus 6 would equal 7 minus x. Notice that you still have a radical, but you started off with 2 square roots, and now you actually only have 1 square root. So now I'm going to move everything except the square root. So I'm going to subtract x, and I'm going to subtract 7. So I have 2 square roots of x plus 6 equals negative 2x. I'm going to divide by 2. And now I'm down to 1 radical that I can keep going on here. So I'm going to square both sides. Now, when you square the negative, you're going to get a positive. I'm going to move everything to one side of the problem. I'm going to factor. And then I'm going to set my parentheses equal to 0. So I did a lot of work there pretty quickly. But ultimately speaking, I'm going to isolate one radical. I'm going to square both sides. If it's a binomial, I'm going to have to FOIL it. If there's still a radical, I'm going to have to isolate that radical again and square both sides. So now I have 2 answers that I want to check. I have 3 and negative 2. And I got to move myself back up to the top here. I have 3 and negative 2. So let's go all the way back up into the beginning, and let's see if 3 and negative 2 will do when I do this one. I'm going to change colors here. So let's say I put 3 in. All right, the 2 answers I'm looking at are 3 and negative 2. If I put 3 in, 3 plus 6 plus 1 on the outside, does it equal 7 minus 3? So that's square root of 4 on this side, which is 2. This would be square root of 9, which is 3, and 3 plus 1 is 4. So if I plug 3 in, it doesn't work. Like that is not a good answer. So that one looks deceivious. Like it looks tough because ultimately when I put 3 in there, it does not work. So I got to cross that answer off, right? X equaling 3 doesn't work. But let's try negative 2, and I'm running out of space here. So negative 2 plus 6 would be 4, and the square root of 4 is 2, plus 1 is 3. So the left-hand side is 3. 7 minus a negative 2 is the square root of 9, which is 3. And that works then. So the only answer to this question is x equaling negative 2. So don't assume that just because you get a negative, that means that's the one that's not going to work. You need to actually plug it in to double check for an extraneous solution, something that may not work in the problem. And it also doesn't mean that every single time everything's not going to work. So you have to double check your answers here. This next one, I want to isolate the 3/4 power, and we're going to talk about this. And most of the time, when you're trying to get rid of an exponent, basically you want the opposite. So I want the inverse of this, or I want to take both sides to the 4/3 power. Because when I take something to a power, it actually multiplies the powers together. So 3/4 times 4/3 would be 1. And so now I'm taking 27 to the 4/3 power, which is 81. And then I'm going to divide both sides by 3, so x equals 27. Now we've done everything kind of with even roots. Now let's start, or one more time. I'm going to take both sides to the 2nd power. I'm going to get everything on one side because it is a quadratic. I'm going to factor it and set the parentheses equal to 0. So again, you don't have to factor these. You can do it in a different way if you want. You can do the quadratic formula or something else. Now, remember, when you square both sides, you should always double check your answers. So 4 plus 12 raised to the half power. So 16 to the half power equals 4, and that's true. Negative 3 plus 12. And so that's 9 raised to the half power is 3. And wait a minute, that doesn't work. So negative 3 does not work when and only positive 4 does. Your homework assignment is out of the book. Sorry about the bells going off in the background. If you have any questions, please reach out to your teacher, and good luck.